to share with you today. Goodness. We got it. But yeah, so there's a lot of fun things to go over. We're going to be telling you guys a bunch of updates for this coming semester. Go through all the projects, go through all the events we got coming up. We will recaps of like past semester, as well as some intros of like what this organization is and the leadership behind it and what makes everything kind of tick here. And then in the secondary hour of this, probably starting around like 7:45 to 8, we're going to have a speaker from Alpha Paris come up here and give a presentation as well. So yeah, I guess I could start off. Just make sure you signed in. And if you haven't, if you're in the Discord, there's also a sign-in link there if you need to hit that after the fact as well. All right, yeah, so here's kind of what the agenda is going to be looking like. So let me move this as well. I love that you can just only see like the bottom half of me. Perfect. But yeah, so again, intros, talking about projects, and we're going to go to some of the pro dev stuff we got going on, some social events we got going on, service events, some closing remarks, and then again, speakers. And then after the fact, I think we have a few slides on this. We got bowling that's going on after this at the Oviedo bowling lanes. I believe it's $6 for college students, and I think it's $1 drinks. I don't know if that means like beer or like whatever, but possibly $1 beer. So that's pretty good. All right, so yeah, welcome back. Oh, comic book stands, let's go. All right, cool. So yeah, what are we? This is for many of you, you just see like Ieee, like that's cool. But like we're the Institute of Electrical and Electronic Engineers at UCF. I know it's sometimes a little bit daunting to people that aren't in the ECE department, but what we really are, it's not just electrical and computer. We're here to give opportunities in a variety of different fields to anyone that's interested. If he's interested, we have opportunities. If you're interested, we have opportunities. Really anybody, anyone that comes up to us, it's mechanical, electrical, computer. Heck, if you're an art major, we have opportunities. Business major, we have opportunities. Yeah, so and there's some cool pictures there from our solar charger workshop last year. So yeah, let's just keep rolling on in. So some more information about, and this will be important in a future slide, but we are in the region 3 of IEEE, which is the southeast region that you see. That also includes Jamaica. Some cool like facts up there. A lot of you have seen this slide already, so I won't spend too much time here, but keep in mind, southeast region. We'll be talking about that in a sec. Oh, and here it is, the southeast region. So each year we have our annual conference that is in the end of March this year into early April. Yeah, so March 31st to April 3rd. This year it's taking place in Mobile, Alabama. Some interesting details on it. A lot of the events are going to be held fully remote. But we're still considering sending a small delegation of students to this event in Mobile, Alabama. So basically what this is there's a bunch of different competitions ranging from software to hardware. We're actually not doing the hardware competition this year, but they also do have competitions where we present research, where we present, there's an ethics competition where people compete on ethical practices within the engineering field. A lot of different realms of this. If you go to this link and you have interest in possibly participating in this, put something on your resume if we're able to win some of these competitions. Hit that QR code there. We'll also be posting it after the fact as well for you guys if you're interested after the fact. And there's more information on all the events in there as well. So if you're interested in that, hit that up. Or again, when we post these links after the fact, that's also a good way to go through it as well. All right, so yeah, here's some just more cool pictures that we had from this last year. So, oh, there's also me. So here's some cool events. Like we had some of our GBMs are up here, some of our service events that we did for lower school students. There's us working on our electric vehicle down there. Here's one of our workshops. There's another one of our workshops. There's a lot of cool stuff. Just a glimpse into what last semester was like for you guys that maybe weren't here or didn't go to all the events. There's a lot of really cool stuff that's going on here. And we're going to be continuing this same type of thriving atmosphere for you guys into this next semester. And I think it's going to be a lot of fun. We have a lot that's going to be going on. What is up? Oh, is it waiting? Can you let him in?
Yes.
Oopsie. Oh my God. Well, luckily it's recorded now, so they can go back and watch. Also, luckily I haven't said anything too important, but okay, yeah, welcome to new people. My apologies for that. So yeah, fun times. Okay, so some cool introductions. Unfortunately, some of our exec team is not here because they're currently in senior design and they have like some boot camp today. So some of them aren't here, but yeah, I'm the president. My name's Alex Parody. It's a pleasure to see you guys.
What is up? What is up, oh my God.
Cool. Big thank you to Lance for getting this room reserved. Andrew's our VP. He's not here, unfortunately. And then Tony.
I think we should go to the pregame and not go out.
He was just here.
Personally.
Whatever. You'll see them coming in a little bit later. But yeah, Tony's our treasurer. Oh, there they are. Right on time.
I think we get them.
Tony's actually working. For you guys' information, we'll have a slide about this. Maybe I'll just wait for that. But Tony has an announcement to make in a little bit here. So more intros. We have our project, a lovely project chair, John Gerlach here. Oh, young John. We have Abdul is also not here for design, so he's our pro dev chair. We'll be speaking for him a little later. Antonia, our social chair, is in the back, and Natalia, our service chair, is also in the back there. And then Brandon, I also think is unfortunate in senior design, but he's right here. And then Mohammed. So a little show notes for you guys on Mohammed. So he actually accepted a job offer for working for Tesla this semester. So he's currently actually working in the Fremont factory out in California. So he's going to still be helping us a little bit, but he's definitely, his role is going to be a little bit more hands-off. He's going to be working a lot more through the marketing committee that we've been building out the last year. If any of you guys are interested in marketing roles, just please reach out to myself or Mohammed, in this case over Discord. That's probably the best way to get involved in that field if you're interested. But also congrats to Mohammed. Like, he's killing it out there. They're working him a bit hard, but like he's still a straight killer. So we'd love to see the success from our members. Oh yeah, as I mentioned earlier, bowling night after this. We'll be a bowling center. We'd love to see it. We'll be talking about it a little bit more too. But yeah, if you're gonna leave midway through, feel free to come out. We're gonna love to see you guys out there. Probably gonna honestly like run up the whole place. They're gonna be shook. Okay, so Tony, yeah, if you want to come up here real quick and talk about Tony Dues.
What is this picture, bro?
Hey everyone. I hope some of you know me. That was a goal I had last semester, so I'm glad about that. So like Alex said, I got a co-op position and it's like full time, so I'm working 9 to 5. So that's probably why I haven't been as active and you guys haven't seen me around campus as much. Sorry about that, but not much has changed about dues. Same process, like fill out like the membership form. Hi. Oh, hey everyone. Okay. Do we have like the QR code for the membership form somewhere on this? It'll be posted later.
Yeah, we'll drop it again in the links after the fact.
But yeah, yo, what's up?
Alright, so I put up forms.
Mm-hmm. Oh yeah, like I think on the form itself it said like all the payment options.
Yeah.
So like, and on it was also like the Cash App ID. So you just put that into the Cash App along with your payment with like the little description like for IEEE membership dues, and like that's just how we sorted it out. So sorry if we didn't make that clear. We'll work on that. What's up?
We can work it out.
No, we can work it out, dude.
Additionally, we're going to make a more streamlined version of this. We're actually working on doing this through the app that we're developing currently for IEEE. So in the future, we want to have it that, and all you guys that are currently members will be able to seamlessly kind of transition this over as well. But we want it so that you can be able to, pay for membership through the app and also have like, custom member number that's there that would be on your phone. So it's like, it's all there. Less of the like public Excel files that we have and more like we have the back end that we see the front end user interface. So I'll be looking forward to that. That's probably going to honestly be a next year thing or a middle of this semester thing. So yeah, hopefully we'll have it more streamlined by then. Sorry.
Yeah, it's all good. Like before, Cash App is preferred. Like I said, I'm not going to be on campus as much, like ever. I don't think I'll ever be here like during like normal hours. So Cash App is like the highly preferred thing. Yearly is like $25. Semester is like $15. Yearly is like 2 semesters, obviously. Not counting summer, spring, fall only. So like if you pay yearly for this semester, you get this semester spring and then fall of next year of the next fall semester. Semester is straightforward, and then t-shirts, which I have over there, I'll be handing them out after this for anyone who needs to pick them up or wants to buy them. Just come see me over there after the whole GBM. $15, or if you're a member or you're paying with your membership along with it, $10. And then the last big announcement is I know at the GBM the last GBM of last semester, I talked about the assistant treasurer position, and I'm proud to say that Nicholas Alm is the new assistant treasurer of IEEE.
Oh, let's go. There you are.
Hey! But yeah, he's going to be helping me out a lot with basically being the main liaison between all the different projects, the committees, and like basically helping me communicate with everyone to make sure we get funding wherever we need to get it. So glad to have you on board, Nick. I think that's about everything for me. So yeah, sounds good.
Sounds good. All right, awesome. Thank you, Tony. All right, yeah. So I haven't really decided. Andrew set this one up, but I think we have a new episode that's dropping. I don't know if there's a date on here, but yeah. So new KOC episode. I believe we have 2 from this season currently published on our YouTube channel, as well as the entire first season up there. Yeah, there's the playlist right there, actually. Yeah. So we'll probably post that link later as well. But yeah, have that upcoming episode. This is okay, sick. PhD student. Yeah, cool. That'll be a pretty interesting perspective. You'll be able to hear kind of like what grad school is like within the university, especially within this college. So kind of what that whole process is about, and be able to hear from the perspective of a student, also from student interviewers as well. So additionally, I don't know if we were ever doing, you guys can ask questions as well, but we might roll that out later as well. Have a place where you guys can request questions that we can ask in these interviews as well. So look forward to that. All right, let's go to the next slide. Okay, yeah, merch drop, let's go. I was having like a little like, all right, so. All right, so very fun merch drop. So we're trying something new here. We're trying to do basically like limited quantity merch drops throughout the semesters. This is the first time we're doing this, so forgive us if it's a little bit bumpy here and there. But basically, how it's going to go down. We're going to have basically a shop on our website. We're going to make it go live around probably noon tomorrow. So keep that in mind if you're interested in getting one of these. Basically, how it works, there's a quantity. Everyone has a lot of questions. There's quantities of basically 50 for each of the items that you see on this screen. And once they're sold out, that's basically it. We're not replenishing them after the fact. We're going to go on to, in a future merch drop, we have different items, and then the process kind of continues from there. $15. Oh, oops. All right, that one is wrong. I copied and pasted that and just changed the font color instead of the wording. That should be sweater for 30. My bad. That one for 30. Yeah. What's up? Yeah. Well, I showed it to him and he gave me a little chuckle, so I was like, okay, cool. Enough consent for us. He will be getting a free one. So yeah, look forward to that. We'll be posting more updates about this and probably also posting on the Instagram any updates from this, as well as on the Discord. So if you're really interested in one of these, again, there's going to be only quantities of 50. So just be on the lookout. We'll be posting any updates if any of the timing when everything goes live changes. So but yeah, get excited. Future drops should also be pretty interesting as well. All right, partisan workshop. Oh my God, let's go. Let's go. Workshop time.
Good evening, everyone. My name is John Gerlach, and I'm the project chair for IEEE UCF. My main job is to oversee all the workshop projects that go on over the semester, so you guys can get as much experience as you can. The first one we have upcoming this semester is the DIY multimeter. This is going to be very similar to how the Arduino workshop worked last semester. So you won't be able to take these home, unfortunately, but it's going to be very involved in terms of programming and wiring basic Arduino concepts. So once you go into this and build this multimeter, you'll be able to get a pretty good understanding or strong foundation of simple Ohm's law, KCL, KVL stuff that you've learned in either circuits or going to learn in circuits. So if you do this workshop, you're going to get a lot of good experience with programming, breadboarding, and circuit analysis right out the gate. So if you guys are new to that or sounds interesting, look out for a sign update that's going to be coming up here on the 12th of February, and we're going to be prototyping this probably tomorrow. So pretty exciting stuff. So look forward to seeing you on that one. The next one we have planned is the solar charger workshop round 2. This one isn't going to be a standard. It's not going to be the same way we did it. We're going to make this mutual inductance, meaning you can charge this wirelessly. through solar power. We're still working on how to build that schematic out so far, but that's how usually mutual inductance works. Is just wires hugging wires, and then you have a charge somewhere. So on a basic level on that, but to gain experience with this, you're going to be able to solder electronics, learn about renewable energy applications with solar panels and solar cells, and how wireless technology application with wireless charging works between all those connections and electronics. Next, this is something we had to push back from last semester, but it's the radio transmitter and receiver. We're working tightly with the radio club on this, just so we felt like this was a bit more complicated than we initially thought. So we want to make sure that this comes out as smoothly as it can for all you guys. You'll be building both the transmitter and the receiver to either play music, talk, or kind of have your own radio or walkie-talkie, so to speak, which will be pretty interesting. So, and similar to the solar charger, you'll be able to do soldering electronics all together on either a PCB or together themselves. We'll still have to figure out how we want to do that. And signal analysis and radio communication applications. So if you're going to somewhere that goes really deep into radio technologies, then this will probably be a good workshop to put on your resume. So they're like, oh, I mess with this stuff too. I touch with FM radios. So that'll be pretty fun and exciting to going forward. And our last one for the semester is going to be a lockbox. So this one's going to be pretty heavily coding based. You'll be doing this all in Arduino. And with this, you're going to be wiring everything together using a keypad. And inside the keypad, inside the programming for the keypad, you're going to output your code or combination for that lock. I couldn't get a video to play, but that picture in the middle is going to be locked with a servo. So if you type in the correct combination, a green light turns on and flips the servo over. And if it's wrong, keeps it locked and there's a red light that flashes. So if you're looking to get a lot of embedded programming in and just learning how to do Arduino for the basic stuff, this is going to be a great workshop to you. And you can take this home. So if you want to put your money inside of it or anything you want, then that's all there for you as well. But I think that's it for the workshops. Alex, do you want to talk about some of the electrical project?
Yeah, in that lockbox you put your valuable merch. No. I play. Oh yeah, so cool. So some project. Oh, and additionally as well, we're still considering possibly introducing a few more workshops as well. But those are the baseline 4 that we're going to be having for you guys this semester. So definitely a lot of fun stuff. Thanks, John, for kind of leading the charge on that with your team. Okay, yeah. So the Super State Racer. Yes, this is one that myself and Chris, who he just graduated, but he's still working on this project as a co-lead. We've been kind of working together on this. So here's currently what our meeting times are. If you're at all interested in this project, definitely please join in the Discord. I believe all of these project channels that we're going to be referring to are pinned in the project channel in the main IEEE server. Eventually with our Discord bot, we're going to have it so it's more consolidated. You don't have to go to a separate server in the future. But currently, this is the way that we have it laid out for this year. So please join that if you're interested in this. Basically, real quick rundown. What we're doing is a dual electric hybrid vehicle design, uses supercapacitors and lithium ion batteries together in order to possibly extend the life cycle time of your lithium batteries. We're working pretty closely with Dr. Patarse on this, and we're moving to get a quote on a battery pack as well as start purchasing motors for this. So one of the biggest things, so slightly bad news, we did get rejected from our research proposal that we submitted last semester. So with that, now we're just going to start purchasing items from IEEE and sponsorship funds. So that's kind of the good news, is now we're not really kind of tethered to that, to the timeline of that grant. But yeah, so we're going to be purchasing items for that right away. So basically what the 2 different meetings are Tuesday meetings from 10:30 to 12 that are going to be in the engineering atrium so that we can utilize MATLAB and the computers there. It's primarily based on MATLAB and getting research for a literature review for publishing a paper and poster board at the end of this semester. And then our second meeting of the week is going to be Wednesday at 7:30 to 9, and that's going to be in AGC 450. That's the room all the way at the top of this building. And that one's going to be primarily focused on building the physical car, while this, again, the first one is going to be more on the research side of the project. Let me see, did I miss any major updates? No, I mean, that's basically kind of like what the rundown is of this. Yeah, the memery kind of picture there of me, that's the vehicle that we currently have. We've removed the combustion motor on there and hoping to put in the lithium batteries and the capacitors and the electric motors and integrate our schematic in there as well. So a lot of fun stuff there. Secondly, so Phantom Arms, Hanny, I don't know if you want to come up here and say anything. But any wise words, Hanny? Anything?
Join Discord even if the meeting times don't work for you, and just let us know when you can do a meeting. Might change them around for that.
This is big facts. Yeah, as I said before, join the Discord for this. I believe the link is up there. Let me see if I can move some around. Can I shorten this or? Well, whatever. But yeah, basically for you guys that maybe have not seen this project, this is our telerobotic haptic arms project. Basically, it's been a lot of robotics and mechanical based, but we also need a lot of people that are skilled with electronics and power supplies for this. Basically, what we want to have is a user interface that when the user's arm moves, a robot arm that we have across the room that's completely isolated from the robot would be able to also move its arms in the same pattern. Yeah, again, Henny's leading that. We've had a good team that's been working on that with Dr. Park's lab over the last semester. So a lot of pretty interesting designs on this, a lot of stuff that's going to be utilized again for research papers. So if you're interested in getting that on your resume, getting some cool experience, it's a pretty young team too. So really like any experience level for any of these projects, please come on and join in if you're interested. Okay, yeah, so I don't know if Jackie's here. Jackie? No, okay, he's not here. So yeah, Jackie and his team have been working really hard on the LED sign project that we've been working on. So the PCBs for it have been ordered. The next big step for this is we're going to be having pretty soon here, probably in the next month till around like early February. We're going to be assembling a little team to build the LED signs that we're going to be. I don't know if we have a picture. Oh, it's stuck behind me. Yeah, this is basically kind of like the benchmark of the design that we've been looking to kind of mimic. It's going to be utilizing, it's going to probably be the UCF logo as well as like the Nitro mascot logo that are going to be in the signs. So really cool stuff there. You'll have the chance to build a few of them if you're interested, and then we're going to be selling them to the general populace so you guys can take these home. And it's a good fundraiser for IEEE so that we can fund some of these other projects. So yeah, if you're at all interested in that, obviously join that server as well. So I don't think Miguel is here either, but so yeah, the LED sculpture project, this is one that we've been working on. The cube is fully built. I don't think we actually have a picture of it fully built here. Here's it halfway built there. But yeah, the cube is fully built. Currently, they're working on the prototyping for the software side. So if you're at all interested in that, definitely recommend getting involved. Current next steps, again, getting actual patterns being displayed outside of just being able to function with lights. Secondly, it's going to be integrating the photonics side, which is going to be based on lasers and sensors. So if you're at all interested in that portion, definitely recommend, or if you know somebody in photonics that's interested, definitely recommend. And then the latter part of this semester is going to be focused on getting our design for our second version of this, which is going to be hopefully a large scale Pegasus that's going to have similar functions, and that when you put your hands over the laser apparatus, it will change colors to whatever the LEDs will change colors to whatever laser you put your hand over. So that's the big brain goal at the end of the day, and we're hoping to put this in the middle of the HEC atrium upon completion. So that's a cool thing that, you know, when you come back to campus in 5 years and it's still there, you can be like, yeah, I helped build that. And really cool thing that you can talk about to your kids 30 years from now. Oh yeah, so the first meeting for this is going to be this Monday, and that's also going to be up in HEC 450, and that's at 4 o'clock on Monday. And they'll be deciding other meeting times based on the attendance in that meeting and what people's availability is. Okay, cool. So cool stuff for this. So Lucas Saber, who's the overall project lead for this and also the firmware lead, is actually currently at the SGA Senate asking for money for this project. So if we get approved for that, I'm hoping, bless up, I think Lucas will be able to give a good talking to the people. So we'll be having all the parts for this shipped in pretty soon. Basically what this project is our autonomous chessboard that we're also making a custom made AI and machine learning algorithm for. We're utilizing a lot of research from Google and other platforms and their chess AIs in order to develop our own. So if you're interested in all on the AI side, or you're interested in some pretty basic firmware, but also stuff that's like, you know, really good hands-on experience that's very translatable, definitely recommend you guys getting involved on that. And yeah, so hopefully we'll be getting assembly and testing working, probably not January, actually, that's probably February. We're going to be getting all the stuff in pretty soon for this. So really good progress on this. And yes, so here's some, no, this one. Oh, well, sorry, it's going to be this February. That date is wrong. So here's some of the designs from it. Here's like the current display of what the computer kind of sees with the chess portion of it, like the actual just like program side of it. Yeah, up here is some like 3D models of it. Here's one of the PCBs that we've been working on.
So that is machine code averaging each position based on a loss rate. So it's able to calculate the best optimum move in a given situation. And it shows each iteration it goes through, it's getting a better, lower loss rate, which is what we want our machine code to do. And for more insight, the one in the middle, the computer and AI was able to get checkmate in 3 moves, playing randomly. So that's a quick thing. Anyone in here on this team? You want to raise your hand at all? That homie over there, Hayden over here. These guys have been doing stellar work on the hardware side. I just want to give a huge thanks to all their progress that I've been doing on this project. It's been absolutely phenomenal. So if you want to give them a round of applause.
Let's go. Yeah, I think all of our AI team is currently actually in a meeting for this project. So that's why they're not here. And then yeah, again, Lucas is currently got his hands full. But yeah, we'd love to see the progress we've made on this. A lot of really good design and research progress. So really cool stuff. All right, Disinfection Robots. So this is one that we've kind of had on the back burner for a little bit, and now we're going to be hitting a strong revive on this year. So if any of you guys are interested, we are looking for more people for this. A lot of the people that worked on this previously have graduated.
Hello?
So we are in need of a few people to help with the assembly of
Oh,
the
wait.
parts that we currently have for this robot. Then
Hello?
eventually
Can you
the
hear me?
prototyping phase, and then
Oh,
any
wait.
troubleshooting that we have to
Hello?
do in order to get our software properly functioning.
Oh,
at
I
that
am?
point. This is definitely a really cool one. We basically have like the majority
Okay,
of the
give me a
parts
sec.
in
I
place.
gotta
Like
fix this.
the UV lamps are there. We just need to build it all, and then we're gonna be the end goal is to donate this to the UCF Health Services building at the start, around the start of March, after we assure that this is safe and none of it will break and it will be reliable. Let me see if I missed anything on here. Oh yeah, additionally, we're also going to be publishing some papers on this one as well, and presenting this project probably in March at the Scholar Showcase that UCF is hosting. That's really kind of what like a lot of these projects are for, get very tangible results in both a physical product as well as research papers and posters that you can show off and really put that in your portfolio and show off to employers in the future. So a lot of really good opportunities here as well. And yeah, again, another one, Discord. It's in the projects channel. Oh yeah, also point of contact for this is going to be Casey and Hal, and then really me and John as well. If you need any information on this. Discord bot?
Yes. Discord bot. All right. So the IEEE Discord bot, we kind of like hinted at it throughout this entire meeting today, but it's a UCF or a IEEE Discord bot that we're going to be using to better optimize our current Discord server to give out more reliable notifications, everyone able to join servers that they want to in terms of projects and workshops. And we're attempting the first implementation we're going to try to do is role assignment. And what this is going to do is you're going to be assigned a role based on your major and current track. And it's going to put you in a separate channel to where you are putting like-minded people with the same track and degree that you are in. So it kind of centralizes you guys and kind of form a little community. Or if you have any advice with people on a similar track as you can ask them. But it's going to be small things like that we want to try to implement into our server, so things as a community kind of flow better and everyone is kind of up to date with everything that we have going on. So no one's missing out on things and everything is all in a uniform type place instead of everyone just getting hurled a bunch of information at these GBMs. So I know there's a lot going on. So the main thing of this is to get everything a bit more efficient for it. Yeah.
It's a next Friday at.
Yeah. Okay. So it's going to be this Friday at 8 p.m. probably, and we're creating the GitHub for it this week, so we can have everyone code on it at the same time as much as we can, kind of going over the GitHub basics and all that stuff. So if you're still new to GitHub programming, this is still open to beginners. So even if you don't have any experience with it, then this is a good opportunity for you guys to learn all the higher level languages. So going to the next one is the app development. Again, it's been dropped in throughout this entire meeting, but it's to make the experience for our members better with an IEEE in terms of information, communication, and overall accessibility to all of our data for you guys. So with main app, we want to try to do is kind of migrate everything we have on our website to this app. So you don't have to keep going to a website URL if you're on your phone on the go. You can either sign up for workshops, pay dues, buy merch, see what projects we have going on in their progress, and all the GBMs and dates with our current calendars connected to them. So with all just all that getting implemented, we're going to be using progress web applications or PWAs, and we're going to be figuring most of that out as we go. Brandon is, again, he's a senior designer right now, but he's going to be the main guy you guys want to talk to if you are interested in this project. And again, still like very beginner level stuff. So if you want to get into app development, this is the project.
Yeah, one more thing before we move on. So long-term goal for this as well, after we do get the preliminaries out there, you kind of want to take this to a realm of like some interesting concepts of maybe having it be kind of like a sandbox type of environment, obviously with precautions so that it's still safe for everybody's data, but basically looking into the concept of the users being able to add in features to the app. It's something that we're still talking about, but keep that in mind that could be an interesting thing that you guys can get involved in the future. Like if you're interested in kind of having the app be something that is really useful for you, you can go in there and possibly work even after it is fully published with getting added revisions and added experience with app development. Cool.
All right, and then going over the last set of spring and future projects, we mentioned all 5 of these in the last GBM fall, but to ensure that we finish all of the current projects we have right now with excellence, we want to make sure we take this as slow as we can instead of throwing out 5 projects all out willy-nilly. So we're delaying these 3 projects right now, but the cooperative drone system and the piezoelectric sidewalk are under research at the moment. So once those, we're getting pretty close in terms of what we're wanting from these projects and how we want to get them off the ground. But once those are done, we're going to be talking with other student organizations of engineering that are pretty well respected within these ideas of our projects. So once we discuss with them, we're going to go ahead and get these projects off the ground, probably starting in next fall.
All right, sick. Oh, what could the next slide be? Oh, it's not. Okay, well, cool. Oh, our sponsors. Woo! All right, yeah, thank you. Honestly, thank you to our sponsors. They're the only reason that we can go and actually like finish some projects that we have going on. So big thank you to our sponsors. We'd love to see it. Okay, so yeah, next slide. Oh, giveaways. Oh! Let's go. Okay, so the first one, we're gonna start off. So yeah, we have a bottle and some bags over here. This is what the first raffle is going to be. So Lance, if you can tell me who our first winner is.
All right.
Oh, shit, big deal up here.
Well,
You see a big deal.
imagine you see this.
Oh, there it is.
The winner is Alyssa Bengala. Sorry for the no.
She might
Oh,
be-
is she in Zoom?
Oh, she just commented, I think.
Hey.
Do you want bottle or bag? This one's a bag. It looks like a little purse, but it folds out to like a bag. You can ask us later. You can tell us later if that's better, but. All right. Bottle. Okay, cool. Send it aside. All right, cool. Yeah. DM John. His Discord is Blade of Volts to try for pickup time. What's up, dog? All right, if you want to. So the next one. So the next 2 here. You have the option of an IEEE T-shirt. Whoa. Ooh. Or secondly, an IEEE PCB. Ooh. So I think so this one is I believe these are like controllers, right? Like
Right. So the purpose of that, it's a little microcontroller where you can have different little functions. It's almost like a Game Boy kind of thing. But you can like mess around with LEDs, but you just have to solder it yourself.
but we can help you solder.
Yeah.
So yeah, it's up to you what you would like. It's T-shirt or PC.
All right.
All right, let's spin out.
Spin the wheel.
Oh, hold
I can do this.
Alright. And the winner is Matthew Ackerman. Is that-
Oh my
goodness.
Let's go! What do you want?
Are they just the regular t-shirt?
It's a regular
I
t-shirt.
already have that.
Here, I have an
Oh,
idea.
hey, we have a taker. All right, cool. Show him the old drip, bro. Oh my goodness.
Okay, okay.
Classic, yeah. All right. Same thing for this one. So third draft. Number 3, my lord.
Alright, I got you. The winner is
Is it backwards?
yeah,
Unfortunate.
Maria Tran.
Oh, let's go! Let's go.
You can do white, green, or
We have more?
So we have
I did separate colors.
Oh, it's sick.
Yeah, I mean it's all the same. Like they're all the same color PCB, but it's like lights.
Oh, the
The
light.
LEDs are different. Yeah, so it's a blue one. All right.
I didn't even peep that was the case, but good looks.
Yeah. Congrats.
Should we do a fourth one for the memes?
Yeah, I mean, we could do a fourth.
All right, we're gonna
Do
do a
it.
fourth one for the memes. Fourth one.
All right.
And,
This doesn't help, but I think it's fun.
yeah.
Give away. I want it.
Alright, the winner is Patrick De Freitas.
Oh, young Patty. Yo, let's go.
Okay.
Well, I have more. We can give this one a loan.
Okay. Sure.
Remind me to give you one.
Yes, please.
Alright, that is all.
All right, cool. We love some good giveaways. All right, on to the next. I think the next is professional development, and Abdul is not here. Aw. But I like to see myself though. Unfortunately, that one was caught on camera. All right, awesome. So upcoming pro dev events. So these are currently the ones that we have so far. We're going to be going out some more events such as mock interviews that we did last semester. We also have some collaborations with other RSOs that we're going to be doing. A lot of the stuff too, where it's like workshops we did in the past for pro dev. We're going to be introducing them again, but with more insight from other organizations. So you're getting not just our perspective, but the perspective from people that have different industry experiences and have all this different background that they could possibly benefit you in different ways than just us can provide. So yeah, resume critique workouts, and I believe the other one, what's that odd one? The headshots, right? Yeah, okay. And headshots. We love headshots. Headshots are good. Get the good LinkedIn profile. So yeah, we'll be posting updates to this within the Discord. Here's currently the bi-weekly schedules for them. So Tuesdays are going to be resume critiques, and then bi-weekly on Thursday currently. Milk and Hall. That's a great picture. That's a great place for some pictures. Get some good fountain shots up there. We'd love to see it. So additionally as well, there's some open posts for our committee. Unfortunately, a lot of our committee, actually the majority have been graduated last semester. That's why we were able to put on a lot of really good events last semester, but fortunately now most of them are gone. So, really, even if you guys are pretty beginner level, we can still help you and kind of get you guys to get some more experience by taking on one of these leadership roles. So if you're at all interested, we'll be posting. I believe actually Abdul has this in the pro dev channel. So if you're at all interested in helping on the pro dev side of the organization, it's super important. As much as we love our time in college, it's important for us to prepare you guys as well for being more professional within the industry and opening as many doors as possible when we get in the industry. So these are important roles. If you're interested at all, either fill this out or please let us know directly. Okay, social events. Let's go. Ansel, you want to come up here? Oh, and I am. I'll start off before I hand it over, but partially training for 3v3 basketball, but we'll be in the RWC every Saturday from 9 to 12 a.m. If y'all trying to get that smoke. Luke knows.
Perfect.
Yeah, trying to hoop up.
How's it going, you guys? My name is Dimitri. These are some of the IM sports that we have. And currently, we're doing volleyball, dodgeball, and soccer. We have one more game, one more like regular season game for soccer. So if you're trying to join that, I mean, now's the time because then it's like the postseason, and you can't join right after the regular season. For volleyball, we have like 3 more games going, and then for dodgeball, we have like 4. Also, right here, the QR code, that's for the Google form that we have. We have a few other things that we could do, like kickball, unified basketball, which is where we'd volunteer with like Special Olympics, so it'd look kind of it'd look good. We also have kickball. Oh, we have softball too that we could do if you guys were willing to come out. So yeah, that's about it.
Then, well, tonight we have the bowling night, so I hope to see everyone there. Moreover, we have the Mario Kart and Super Smash Bros. Tournament next Friday. The room will be announced throughout the week, but it will be at 7 p.m. So you can scan the QR code to register and let us know if you can bring any consoles or TVs like to project it. Moreover, we're having a Valentine's trivia night that will be on the World of Beer, Thursday, February 3rd at 7:30 p.m. So yeah, I hope to see everyone there. Thank you.
Oh, bowling, yeah. I can talk about yeah. So yeah, we mentioned this earlier. Just wanted you to know.
No, pues
There might be bowling going. But yeah, so we'll be there. Pretty cheap.
te ataca la parte neurológica, porque en esos primeros días llegué al trabajo y no entendía nada, y avanza le pasó lo mismo. Me hablaban en inglés y yo lenta. Yo de agarrar, había pasado el
Don't everybody come. All right, let's go.
Okay, so hello everyone. So this is the service committee. We're gonna have our next cleanup this Saturday actually. So if you guys are interested, we focus on microplastics, which I hope all of you know are very important. They go in the lakes and the ecosystems, which house all the animals, the marine life, the turtles end up eating it, and it's affecting not only the animals but also the planet. Yes. In a bath. Well, we collaborate with the city of Orlando, so they manage most of it. We just sort of bring the students and the people, try to get as much people as we can so we can help. So they're in charge of all of that, and then they recycle it and they do all the good stuff with it. Promise. So yeah, this is actually really important, and if you guys can help, it would be really awesome. And if you're interested, just sign up. We do a couple of this every semester, and they're very useful for the planet and the community. So we're doing that, and we'll do a couple more, so be on the lookout. And we will also have a table for Engineers Week. Is a fair that will be going February 21st to the 27th. We will be putting up a project and showing 100 K-5 students. That will also have games and different events. If you guys are interested, it'll be fun. So be on the lookout on Discord. We will be sending out all the information for this. And some of you guys went last semester to the STEM outreach event, where we're trying to inspire younger students to be, to be in engineering. And we showcased a house, a turbine, wind turbine.
Meeting I was supposed to go to in person. I was doing on Zoom.
Energy, and we had the turbine, and he turned on a light inside the house. It was really fun. They all loved it. So we're gonna have that. So if anybody's interested, So look out on that one
I don't
as
need a
well.
spoon. It's easier just to do this.
And if anybody's interested in
What's the
being
point
part
of
of
a
the service
spoon if I just
committee, please let us know. We're always looking for
Oh, yeah.
people. We want to create new events that will be useful for the community as well for students to inspire students. So if you're interested, make
What's
sure
the
to
last
sign
bit
up.
of meat I got here?
Awesome.
Love our community.
Yeah, they're getting like teams for like stuff like they play dodgeball, they play basketball.
Oh yeah, okay. So
like,
I
stuff.
think
I was on a
it's online.
basketball team last semester.
So yeah, as
and
you
then
guys
I
might know,
also
from
did,
last semester we gave
football,
out
but
2 of
this
these.
time they're
We've
doing
been
dodgeball
trying to
for
introduce
football.
our
Dodgeball's
IEEE
kind of
Member
fun.
of the Month award.
Oh yeah,
So
you know.
we're not doing
Might
one
try to
for
join that.
December because
Yeah.
for January / kind of February, it's gonna be kind of weird. Let's say January. It's gonna be January.
But like,
But yeah,
that's
if you
like
guys are
what
interested
clubs
at all in
purpose
nominating one
is,
of the
like, getting
keepers,
like
you
this.
want to tell your friends to nominate
Yeah.
you because you
They're gonna have
you've been
tournament
super involved. You can do that.
Really?
We're gonna be opening up a portal on the website very soon that you can nominate people for.
Yeah, we should play
This
some.
month,
I'm
we're
not
gonna
that
be
good.
as a exec team looking
I'm
at
not that
those
good.
and choosing from your guys' submission, which ones we think are
Tennis
worth
stadium.
award. We make little laser
I
code
really want
lines
to
for
play
you guys and
basketball.
give you guys little goodie bags as well.
The last time I played
Oh yeah, there they
dodgeball,
are.
like,
Here it is. Yeah,
the last time I played dodgeball was in
Lucas
high
were
school.
the first 2 winners of this, so you could be the
There's
third
a team.
winner.
There's a team like, have you been to off the wall sky zone before? There's like places like
Yeah, this is a cool way to get recognized. We love.
and there's like
Okay, yeah. So
ultimate dodgeball.
okay, yeah. So just final notes before we go.
Because I was really good because I
I
did
have
dodgeball.
really cool project
Yeah.
ideas,
I
workshops,
wish you back
name it.
past
We're here
the
to
wall,
listen.
Yeah.
Events, cool ways to get
But
involved
like
with the community.
my favorite
We
thing
want
to
to try
do
to make as
was
many of you
just
guys like
backflip
this
and
coming
backflip
out.
and backflip, and people
So
throw
just
the
like reach
ball.
out to anyone
And so as
in
soon
the
as
section,
I
anyone
see
with
it, once I
community,
jump, I
that's
stop.
going to be the best way
and
that we
just
can
fall
make it become
immediately.
reality.
So
We'd
that they
love to
miss
see
the
passion
ball and I
from
pick it up
anyone.
and throw it right back at them.
So, but yeah, so just that's basically what I just said as well. But yeah, any feedback is always appreciated. These are there is a membership form here. Again, all these links will be posted after the fact as well. But yeah, with that, so we do want to introduce our speaker from L3 Harris, Mr. John Patrick. So yeah, you want to come up here? We can get started with the presentation. So yeah, let's transition to that. Do you need me to swap your computer onto here by chance? Yeah, that's totally fine. Yeah, sounds good.
I guess we could look up how to even do that if it's HDMI. Just
I think there's a cord on here.
yeah.
Yeah, I think it would just be this.
I just don't know if it's like display for or not. Made.
Oh, it's still there.
Oh.
Huh.
I will figure it out.
Yeah, just unplug. Maybe this one.
Because we can do, what is this, from computer? For it to be on next to walls. Okay. I'm trying to see how to get this plugged in. How you doing?
Hey, doing okay. Oh, good. HDMI, that works great. I'm going to move this.
Yeah.
And let's move these out of the way. There's an HDMI port right there.
Oh, yeah. I'm going to try to see
I'm
how to
gonna-
change the display to that.
Okay, I'm going to plug this in just to make sure I don't run out of battery power.
I thought you said turn it around. I was like, that's the worst idea.
No,
Never
no,
hear
no,
of
no.
ideas.
Go drive it around. Yeah. Okay. Let's see. Do I have? Does it see it on my side? Window.
You have to stick them on the podium over there and kind of hold them up.
I thought we could pass them around.
Oh, pass them around? All right.
Yeah. Here. He's working on that. Maybe not. Some of them, yeah, some of them, no. Here's going to become demonstration now. Hold on a second.
Trying to figure it out.
Right. I think the way this classroom's set up.
Might be from here though.
Right.
Go to home.
HDMI.
Is it gonna be better if I can get you guys the
Possibly.
Yeah. We'll see.
presentation?
Yeah. I think it's not even
Can you see
working.
if your email?
Yeah, I mean, Sarah has me on Discord, so you can send me the file there. Yeah.
Where's the which is this computer here?
Yes, sir.
Everything's gonna go on that screen, isn't it?
Yeah.
Can we turn off that screen for a moment while I'm?
That one? Oh, yeah.
Or actually,
Hold
hold on a second. Let me. That's okay. That's okay. I think,
I turned them off for
I
you,
think we're good.
just in case.
Sometimes I have like customer information that it might pop up immediately, and
Yeah, absolutely. Do you guys want any water by chance or anything?
I will. If you've got a bottle of water, that'd be great because I'm gonna.
Yeah, absolutely. Alex, can you go to the vending machine and get a water? Thanks. Oh, no.
I got it. I got it. I got it. Shh.
All right.
Yeah,
You
not
ready?
supposed to. Yeah, let me do one thing. If I present, will I get? Oh, no, I need those screens on. You do turn those screens on? Yep.
Yeah.
Should we lower the brightness or just keep it as?
I think we can keep it as is. I mean, if it's really bright, we can just dim it.
Ugh. Can we do this? Can we get this on? Let's see if we can get this. Will I get my notes on the screen?
Oh, yeah. It literally happens since like I would say having really yeah, I would say so. Yeah, like oh, it's first video. So I would say like a lot of like we just have
I'm ready to go when you are, yeah.
Hey guys, thanks for your attention. We're gonna go ahead and get started with the presentation. So let's just bring it down just a little bit. Go and get started.
The way this is set up, I can't, I don't have my notes screen on this one, so I'm gonna have to bring my notes up on here. That's fine.
yeah, no problem. I'm sorry if I can't get that connected. I think it's just something I have wired up here.
It's fine. That's fine. We'll see. Hello. Wait until the presentation is done, and then you can plot if I deserve it. Okay. So, my name is John Patrick. I'm with L3 Harris. I'm actually with the group out over in St. Petersburg. and going to give a presentation here on flight data recorders. So first, our agenda will be a little bit about myself, then we'll go over some Flight Recorder 101. All those questions that you see there, we will answer. We'll end up why we do this, why do we have flight recorders, talk about how flight recorders, the requirements have changed over the years, and then we'll also talk a little bit about careers in avionics and flight recorders. So first, myself. So my name is John Patrick. I've got a bachelor's and master's in electrical engineering from the University of Oklahoma. If you are a college football fan, we can talk about your quarterback later. I had nothing to do with it. I've been designing and working with recorders since 1999. Yes, that does make me a little older than most of you guys, but it's been pretty exciting. Some of the stuff I've done, other than designing recorders, both the hardware and the software side of things, is I participated in some flight data recovery on the military side. You see a couple recorders there that I've done. I participated about 12, 13, 14, somewhere around there, data recoveries. I did not go out to where the incident was. I did not dig in the dirt to find the recorder. What happened is the Air Force, typically or the Navy, had brought us the recorder and said, we can't get the data off, please help us. More than once, they brought a box of charred electronics, dumped it on the table and said, we think your recorder is in here somewhere. Always fun when you get to do that. Thank you. To do that. I'll have some stories about some flight data recovery later on. I have my email address here. I also have some business cards. I'll put my business cards up here, over there. If you have any questions about this at the end, you want to grab a card, email me. I'm always willing to answer an email, phone call, any questions you have. Again, if while during this presentation you have any questions, raise your hand. You guys might not be in my sight line at the time, so you can make a sound or whatnot, and I'll answer it right then. So Flight Recorder 101. What is a flight recorder? So flight recorders, well, they record flight data. Well, not just record flight data, they record a lot of things. But why do we have them? It's mainly to assist in an accident investigation. Now, that was the original reason for them. It's morphed over time. Now we're seeing what's called FOQA, or Flight Operations Quality Assurance, where they're taking the data after flight and looking at it and analyzing it and saying, okay, did we do something to the aircraft here? Health and usage monitoring system, again, it's pretty much the same thing. Although HUM's data is also normally some data that's in addition to what's being recorded. We have a division that's actually takes the flight data and for airlines looks at the data and says, okay, guess what? You could save about $2,000 in fuel every flight if you changed your flight profile this much. Think about how many flights somebody does. They suddenly realize that's millions of dollars in a month. They make the changes to their flight profile. There are four basic types of recorders. The cockpit voice recorder that records the voice, both the crew themselves talking as well as ambient sounds of the cockpit. The flight data recorder, which is your flight controls, your flight and your control surfaces, everything that's not being spoken. Data link, think about it as text messaging in the sky. When flight control wants to contact an aircraft, they can actually basically send what's called a data link message over radio. Instead of contacting them and talking to them, it's a text message. It shows up literally in a scroll by them, and they can see this message that says, change your altitude to flight level 380. Then they know they have authorization to do that. And then you have airborne image recorders. Image recorders are video. Video is coming along really slowly. The flight crews don't like it. Where we are seeing it mostly is in helicopters, where it's actually outside of the helicopter. So, you have a question?
How durable is flight?
Oh, we'll get to that. We'll get to that. Well, I'll show you about the survivability that these things have to go through, and you will be. I mean, they survive a crash for a reason, right? You also have a fifth type or combined type, combination recorder, and that is where you have multiple types together. There's also a deployable recorder, and I think I'll get into this later as well. A deployable recorder is a recorder that acquires data into a memory unit that is actually connected to part of the airfoil, typically on the vertical stabilizer. And when a certain situation is detected, it actually ejects that off of the vertical stabilizer. So it actually makes it leave. Let's see. Air France 447. Air France 447 was a flight from Brazil to France that went down the Atlantic. It took them 2 years to find the aircraft. It took 2 years to find the flight recorders. Had they had a deployable recorder, they would have found that deployable recorder floating in the ocean with all the data, and they would have had a better idea of where the plane went down. They would have had a better idea of what happened, and they would have been able to find it a lot faster than that 2 years. Yes. So the deployable recorders have a couple different types of things. One is the ELTS, which is emergency locator tracker device, which sends it via either 121.5 megahertz. There's also 406 megahertz, 406.5. I don't remember exactly the number, sorry, as well as a satellite link. Yeah, so that's the deployable will have that ELT on it. But if an aircraft doesn't have a deployable and it goes down the ocean, that radio is not going to work very well. You can't see that up there. It says, wait, I thought it was called a black box. Why is it orange? Yes, that's normally the number one thing when people see these boxes is they say, wait a minute, I thought it was a black box, right? So it's bright orange. Why is it bright orange? Well, it's bright orange so that when you have an aircraft that has a unintended ground landing, you don't like to say accident, right? But unintended ground landing incident, crash, you're able to find a little better. Also, of course, there's an engineering term for black box. Basically means a box that you really don't know what's going on inside. If you want to think about it, these data recorders, data comes in and really doesn't come out. You know, we're not feeding a display. We're not providing data to someone else. Data comes in, and stays in. And initially, they painted all the boxes black in the very beginning of time until they realized that if they painted it a different color, it'd be easier to find. So what kind of data does it record? So CVR, the cockpit voice recorder, records your cockpit voice. So the boom microphones, the live microphones that they have, that the crew has. Okay. It's a little heavy. We can pass it around. I'll give you guys a lighter one. That one's about 11 and a half. So you have the crew microphones that are getting what the crew are saying. If they activate the radio, you hear the radio. Matter of fact, you actually hear the radio traffic. In all reality, we're not recording the microphone, we're recording their speaker, their headphones. So when there's radio traffic, whatever they've tuned their radio to, because they might have the pilot and captain might have be listening to two different frequencies, we're actually recording what they're hearing. There's also a cockpit area microphone. Cockpit area microphone. This is much lighter. Cockpit area microphone. This is the microphone that's mounted in the cockpit to hear the ambient noises. One of the things they do when they install the microphone into the DB9 connector on that is because I was doing some testing on it. It normally doesn't come with one. They do some characterization of what the sounds are in the aircraft. And so they'll actually do some flights and record and listen to it and hear that you can hear when the pilots flip switches. Matter of fact, some of the switches sound different than other switches. If you get an enunciation in the aircraft from one of the other avionics, I participated in a data recovery for military. They provided the audio data, and I got to hear the avionics, the TAWS system, the terrain awareness system, go terrain, pull up, pull up. So that gets recorded in there as well. It's not in their headphones, but it's in the thing. It also picks up the sounds of explosions, decompressions. An explosion and decompression actually sound differently to the microphone. And you can actually look at the microphone waveform and determine if it was a positive pressure or a negative pressure on it. So that's actually what has to be done with that as well. So that's what the cam does. the flight data recorder records all the data in the system. So anything to do with the flight itself. So your airspeed, your altitude, angle of attack, pitch, roll, yaw, pitch rate, roll rate, yaw weight, lat long, fuel weights, fuel flow, but not just the positions of the aircraft, not only the position of the ailerons, but it's also recording the input. So when the pilot moves the stick left, we record that the stick was moved left, and here's how the airfoils react. There was a series of incidents back in the 80s, before my time, that actually I was alive then. I wasn't doing flight recorders then, where there was a Boeing aircraft where after some wear and tear, when the stick would go left, the rudder would go right. So very, very important. The flight recorder actually recorded the pilot went left, the rudder made the plane go right. The pilot left a little bit more. The rudder made the plane go even more right. That was recorded. It was able to be found out that was a problem. They took a look at the linkage. Hydraulic system in the linkage was a problem. They had to ground all of those. I think there were 7 Boeing 727s. Tells you how old it is. 727 aircraft. They had to ground all of them and fix them all. So we record both the inputs as well as the outputs. And we record a lot of them many times a second. Things like fuel weight don't change fast. Things like your lat long position don't change fast. But your pitch, your yaw, your roll angles, those can change fast. Your airspeed might change fast. So we might record those at 2 hertz, 4 hertz, 8 hertz. 8 hertz is about as fast as we record most of the parameters because they really don't change much faster than that. Things like fuel weight, you might record 1/4 hertz. Record it once every 4 seconds. We really don't need it because it doesn't change that much. Yes.
All right, so you mentioned before that you guys don't see the data that goes to the recorders as the flight incident.
In the past, that's what they've been doing, yes.
Okay, right. So how much does it only record the most recent flight? And also do you get rid of
I need to show you like 3 slides later because it answers all these questions. No, but this is perfect. No, this is good though. So it records over the oldest data.
Okay.
So we do record over the oldest data because and there's been some studies on how long of data we needed to keep because it very well could be that something 2 flights ago or 3 flights ago may have had an impact on an incident flight, and they've seen that. They've seen that where the damage happened 2 takeoffs ago. So on the flight data, we do keep we do keep that. But when it comes down to the audio, we don't keep the audio nearly that long, although it's changing. So we are keeping it even longer. Sorry, I'm trying to get to my notes on here. Can we get rid of this window up here? Is there a way to minimize this or hide this one? Oh, yes, excellent, fantastic. So what does it do with all that data? So what we do is we record it. Duh, right? It gets recorded in what's known as the crash survival memory unit. Or at least that's one of the terms. So the larger recorder passed around back there. Can you hold that up, sir? Can you hold it up for me? Right. So the round item, you didn't realize you're like Vanna White, right? So the round item on the back there, that's the crash survival memory unit. That's where the memory is stored. And actually, I actually have one of those. I'm going to put this on this side this time. This is actually the memory puck that's actually in that style of memory of crash survival unit. Not much to look at, but you hit somebody with it. Please don't really. But that memory is where we store it, and really, it's just a memory. Think of it about a very protected thumb drive. The rest of the box does the data acquisition. Yeah, you need to go that way. There's the rest of the data acquisition, acquires the audio signals, listens to the digital signals, parses them as need be important. Great, it records the data, fine, fantastic. Who cares? I mean, that's easy. That's really easy to do. Well, a couple of key things. One is the organization by time. I've got audio, I've got data, I've got data link or flight data, I've got data link. I may have video in there. We have to be able to correlate them all. So there are rules. We have to be able to correlate audio channels within 4 milliseconds of each other. Doesn't sound like much. And I'll tell you what, it's really not a difficult requirement to hit. Realize that that 4 milliseconds rule was written in 1956. Maybe you can realize that 4 milliseconds was really difficult back then. Now, not so hard, but that's still a requirement. Time between audio and flight data must be correlated within a quarter of a second. Again, not difficult, but we have to do it. Audio time base has to be 0.1%. So we've got to sample. Our sample variations on audio can only be 0.1%. But the other important thing is not only do we have to acquire that data, we've got to parse it, we got to look at it, we got to store it in that memory, and we got to store it in the memory fast. The fastest is 50 milliseconds. Typically, we end up doing everything at that 50 millisecond rate. But so if there is an incident, if something happens, pretty much the data in that crash survival memory will have everything except for maybe the up to the last 50 milliseconds of the incident. So you know, that's the key thing. We got to grab that data. We got to put it there. There you go. Okay. You know what? I don't think that was selected. So why do we have flight recorders? Accident investigation, training, maintenance. I told you. Oh, here's the deployable. So this is an aircraft. This is an Airbus A350. So here's the vertical stabilizer. Realize this vertical stabilizer is something like 35. Okay, they're lots bigger than you think they are. So you see this little itty bitty mark right here. You barely see this little mark. That's what this is here. The close up of that, and you can see this circle that's there. This oval. I come over to here, point it on this side, right? So here's this little itty bitty mark. Barely see it. Little itty bitty mark right here is this white mark here. This circle right here, this oval right here, that's the deployable airfoil. About this big around. Okay, it's this big. It makes up such a minor section of the airfoil that if this were to deploy in flight, there'd be no effect on the flight. How it deploys, it can't even hit any of the stabilizers back there. But you know, the reason we record data is all this is of course for flight safety. This is what I wanted to get my notes for. So who needs to have a flight data recorder? So who needs to have a flight data recorder? Pretty much all commercial airlines need to have a flight data recorder if you're carrying passengers. Private planes of a certain size or larger, helicopters that are public service, drones, the big UAVs. They've been forcing those to have flight data recorders on them if they're flying in controlled airspace. I'm not talking about your little quadcopters. I'm talking about like the General Atomics Predators, okay? The big guys. Realize that controlled airspace is like here. This is controlled airspace. And some of you might be thinking, oh, well, we don't have to worry about predators flying in the US airspace. You guys are funny. No, yeah. So if they're flying in controlled airspace, they have to have a flight data recorder. Obviously not a cockpit voice recorder. There's nobody in there. However, sometimes air traffic control goes through there. So now there's a big debate of whether or not they have to record the air traffic control going through there. Some of you might also be thinking, wait a minute, why do I need to record a drone's data in the drone itself? After all, it's sending all the telemetry down. I've got the telemetry. Yes. Spaceships. That's good. Okay. Give me 1 second. Let me finish this. I'll get to that. Okay. I'll tell you right now what it is that the safety boards, the FAA with the NTSB, YASAs, which is the European version of the FAA, YASA, their BEA, which is like our NTSB, they don't trust the drone operators, which are mostly the militaries, to have them go, what happened to your drone? And the military goes, yeah, I don't know. It wasn't flying. It was normal. It was nothing, right? They don't trust that, so they wanted the flight recorders on there. So all the big tactical weaponized drones flying over Europe all have flight recorders on. Space, right? Fantastic. So no, they don't. At least they're not publicizing they have it. So I can tell you that the shuttle did not have one. I can tell you that the shuttle approached my company to design one. NASA approached our company to design one a long time ago when the shuttle was flying. And we looked at the requirements for it and we gave them a price tag. And you think, nice, NASA's got all this money. We give them a price tag. It's like, oh, for these requirements, it's going to be like $30 million to develop one. And they went, never.
Which shuttle was that?
That was post Columbia. So it was after Columbia that they came and talked to us about it. So they apparently looked at it after Challenger, but did not consider it. But it was after Columbia, they said, we better have a recorder. And they decided, no, it wasn't going to be worth it, the length of the shuttle program. Okay. Next, oh, thank you. Yeah, I'll take it. It's fine. Also, next thing coming up, urban air mobility, UAM. I tell you right now, if you guys want to get into aerospace, if you want to get into avionics, you find yourself a UAM company and you work for them now. These are going to be huge. I mean, huge. Okay. There are about 6 big competitors for this, including the company out of Germany that has already planned an entire port for their UAMs here in Florida. It's basically Orlando South. And they've planned a fleet, they've planned all these airports. You'll be able to basically hop into these little itty bitty electric aircraft that have like 40 motors on it, pick it up and it'll zip you from here over to Tampa, here to Miami. Okay. It's huge. It's huge. It's coming, and we're working heavily to get into that market. Commercial airspace, everybody has to have 2 recorders. So even if you have a combi unit that can record both flight and data, you still have to have 2. They don't want a single loss, right? So you have to have a flight data recorder and 1 cockpit voice recorder. If you have a combi unit, you still have to have 2 combi units. Always must be 2 units. So typically the flight data recorder is going to be in the tail. It's the most likely survivable location on the aircraft in the case of an incident. The cockpit area microphone, of course, would be in the cockpit. Sometimes in some installations, when they have two recorders, they'll put the CVR designated recorder in the front and the FDR designated recorder in the back. That way, in case the aircraft breaks up into multiple pieces, you now have maybe a better chance of finding one of them. Who uses all this data? Mostly the investigation boards, NTSB, BEA, AAIB with the British, as well as all the safety centers for the military. Training, they do use them for training, and I told you, maintenance is a big thing now. We got them where they're wanting to use the data for better flights and knowing what's gone on. I do know that in the military they do record, they do pull the data every so often and go after the pilots for hot dogging, because I was in an investigation for that. Hot dogging, yeah, that's when they were flying maybe not the way they're supposed to. You know, like they were doing corkscrews and this sort of thing, and that's not what they were supposed to be doing. Yeah. Actually, there was a data recovery I did that we went way back in time. It was on a trainer aircraft, trainer and trainee ejected. They were fine, but we were looking at the data, and we looked at the data and went, "That's interesting." So you have something called angle of attack, which is where the direction you're going versus the leading edge of the aircraft. So if you're going straight ahead, the aircraft, your angle of attack is 0. Most planes fly with the angle of attack between like 3 and 6. Okay, so your leading edge is a little bit higher. So when you got an angle of attack of like 87, it means the aircraft is flying like this. Yeah, and then you see your pitch go from like plus 90 degrees to minus 90 degrees. That means they went up with this. So anyway, very, very interesting. But yeah, they catch those pilots doing a little hot dogging and they get in trouble or not. Not supposed to do that. Underwater locator beacon. So on the recorder that went around, both of the recorders that went around, you should have seen this little beacon. I'm going to pass this. It's a little heavier. So this beacon in the back, that's underwater locator beacon. When it goes underwater, it. Be really careful with this one. Okay, I stole this from the lab. I'm not worried about you particularly. I'm talking about everybody. This is my software called guys unit, and if I bring this back in, how did you get? But you see, there's a beacon on it. Beacon is when the aircraft has a, as they say, when you're on the airplane. In the case of a water landing, right? I always, when they say that, I always say I don't remember seeing floats on the bottom of this plane. I've been in a plane that actually landed on the water, but it was meant to land on the water. But in the event of a water landing and the plane sinking, this sends out ultrasonic pulse that allows them to. Recovery people can tow this sonar type thing behind it and listen for that pulse and help locate it. So those have to be on all the recorders. Yes. Yes. So that's good. So historically, a lot of it has been just when an accident has occurred. Matter of fact, I can name multiple aircraft that basically the only time they care about the recorder is when on their 6-month checklist they have verify recorders installed. Yep, we move on. So only time they even look at the recorder. But as time goes on, we're finding that the airlines, the aircraft operators, the military are finding that that data is useful. That they're able to look at that data and say, okay, this is how the aircraft is flying. This is how how things are going on. If they have a hard landing, right? If they exceeded the turbine speed on their engines, right? We're recording all that stuff. So they're able to look at that and say, okay, we've had an engine over temp event. Okay, we need to keep an eye on this engine. Second engine over temp event. Okay, we need to perform maintenance on this engine. Maybe it's not ready for it yet, but it's time to do that. That's what is becoming more and more popular. But in the past, it was just in the case of an incident. And as I said, there's some operators too still today, they don't care about it. I would say the use of the recorder is becoming more broad. Okay. That, by the way, says, just so I can, what does a flight recorder prescribe to? Somebody asked, you asked what it had to do. Okay. So every recorder, in order to be qualified, has to go through a series of tests. This is the series of tests. First, it's shot out of an air cannon. It's shot out of an air cannon. Okay. It impacts this the lower left, you see the honeycomb absorber there. On the right, you see it's kind of, there's a kind of a carrier that the recorders put in. But we shoot it out of an air cannon and and have it hit that honeycomb recorder and put a 3400 G impulse. 3400 G impulse. It's over 20 milliseconds. 3400 G impulse over 20 milliseconds. Okay, fine, great. We just shot it into the wall. Next thing we're going to do is we're going to try to pull that beacon off. We're going to apply 6,000 pounds of force in all directions to see if we can't get that beacon to come off. It used to only be 1,000 pounds of force. Remember I told you about Air France 447? It took them 2 years to find it. When they found the recorders, the beacons were not on them. They weren't our recorders, by the way, they were competitors. Anyway, yeah. They realized that the sheer force of the incident was actually so exceeded the test, so they upped it to 6,000 pounds. So you should only be 1,000. We had to perform a test with the new requirements of 6,000 pounds on ours. We did not have to modify our holders at all, our brackets at all. It withheld 6,000 pounds, so we were happy. Pin drop, 500 pounds from a quarter inch pin. That's a certain steel pin. It's a certain length. It's a certain hardness. It's dropped from 10 feet. Static crush of 5,000 pounds along all axes. So what happens is we take 3 of these units and we put all 3 through impact shock, through the beacon pole, through the pin drop, through the static crush. Then we take 1 and we bake it. And actually that's a typo. It should be 1100 degrees C. I keep forgetting to fix that. It's 1100 degrees C for 1 hour. That involves flamethrowers, people. Flamethrowers, yes. It's always fun when we get to do a flame test. Low temp fire, that's 260 degrees for 10 hours. That's just a really hot oven. It's not as exciting. And a seawater immersion, 20,000 feet for 30 days. So we did 3 units. We tested them each through those first ones. Then we put 1 through high temp, 1 through low temp, 1 through seawater immersion. At the end, we take the data out. One second, let me finish. We recorded what we put in. We take the data out. We're allowed 0.01% error rate. Yes.
Have you ever lost one in a seawater burst test?
No, because we actually don't really put it in the ocean. we have a pressure vessel that we simulate the 20,000 feet of seawater. It's not impressive. It's this big. It's in there. There's a gauge on top that says 20,000, 50 feet, and it just sits there for 30 days, and then they relieve the pressure and take it. It's not exciting. It's not exciting. Yes.
Right. What about
EMPs? I can't talk about that. Okay. All right. There's another question. Yes. I'm sorry, what? When exactly? So she asked, when do the deployable ones deploy? That's a very good question. So there is a whole set of criteria for it to deploy. I can't share that with you because it's different by each manufacturer. They've got their own requirements for when that is. But basically, there has to do things with attitude. If the aircraft is pitched too high or too low, right? If there's actually an impact sensor in the aircraft, they have some basically some wires that go through the aircraft. When the aircraft, if the aircraft were to break those wires, that sets it off. There are a lot of other things that do it too, but there's a set of criteria. So, and it's actually a spring-loaded thing. They're not explosive. You don't have to worry about explosion happening. It actually just releases a class type of thing. Well, it's about yay big around. I wanted to bring one, and it was currently in use, and the guy wouldn't let me. I'm like, can I borrow it? No, you're not using it. Yes, I am. Okay, fine. It doesn't weigh much. It's like 15 pounds, something like that. I mean, I would not want to be hit by it, but it's not a critical thing. Yes, the back. How much? What's the digital memory size? Well, if I told you terabytes, you'd be impressed, right? I'm not. We're not even close to that. A couple gigabytes. In all reality, there's not that much flight data. Okay. For example, how about this? Your aircraft, your commercial aircraft, your Boeing, your Airbus. The amount of flight data being recorded, not voice, not video, not data link, but flight data being recorded, is a whopping 1.5 kilobytes per second. Okay. Multiply that out by 25 hours, which is the minimum number, and you're at like 100 megabytes. Okay. Audio takes a lot more. Okay. There's probably somebody's going to ask a question about audio compression. We don't do that. Okay. There's a lot of different compression technologies. A lot of them are really bad for data. They lose silence. They lose low voltage signals. They guess. MP3, we can't use any MP whatever. You can't use any of that audio technology because it adds artifacts to it. So we do what's called a companding, a mu law companding. So it's basically 1 byte per sample, 8,000 samples per second for the crew mic, 16,000 samples per second for the cockpit area microphone. It's not even CD quality. Anybody know what a CD is nowadays? Anyway, but it's not even CD quality. You don't need it. You don't need. Yes.
Or is it all proprietary?
So we don't record in any commercial form. because we have to have that, we talked about the time correlation, right? So how it's stored in memory, we've got to have basically time tags saying this section of audio, this section of flight data, data link, video, whatever, is related with this time tag, okay? So every single piece of data that we store, we've got a time organized with it. You don't have that like a WAV file or anything like that. But when we reconstruct the data, when we take the data out and we use our software to create a file, WAV files are what comes out of that for the audio investigators, the investigators. Yes.
Right. So if it can withstand this much, how do you do it?
Well, yeah, I have screws. I mean, it's an assembly, right? And we have a method on how we do this. So this is the drop test and the crush test. As I said, we crushed 5,000 pounds on every single axis. So there's 5,000 pounds and with the beacon on that too. And we have our high temperature fire tests. As I said, they are flamethrowers. The mechanical engineers, you guys are all electrical, I'm sorry, but the mechanical engineers get to flip through a catalog going, oh, it's a new flamethrower catalog. This is good. Kind of. It's really interesting when they make them, when they do the testing. First, they actually categorize the flames, because not only is it 1,100 degrees C for an hour, it has to be certain thermal flux. So they create what's called a calorimeter, water in, water out. They measure the difference in the temperature and based on the water flow, and they can calibrate the flamethrowers to give the right thermal flux. Then they turn off the flamethrowers, remove the calorimeter, they put the unit in there. We always remove the beacon. 1,100 degrees C will melt aluminum. The beacons are mostly aluminum with a lithium battery on the inside, also known as hand grenade in the flamethrower. Yeah, they will explode. So we remove the beacon and we hit it with the flamethrowers for an hour. It's as pretty as these pictures are. I mean, it's exciting for like the first 30 seconds. Yes. And after that's like another 59 and a half minutes of this, I'm going to go back to my desk. Okay, so why we do the testing. All right, so data that comes out of the recorders after an incident helps us learn why it happened. It's, as I said, I've been involved in 12, 13 or so, I don't remember how many now, data recoveries. And, you know, it kind of gets to you when they bring the recorder in and they say, the flight crew did not survive. And so that's what, you know, we get the data out, we give them the data, they use the data, they're able to solve the problem. An example of one of the data extractions I did. I won't say the aircraft, because it's a military aircraft, U.S. military aircraft. They brought us the recorder 6 months after the incident, because that's how long it took them to find it. It's one of those way off nowhere type of things. Brought us the data recorder. Data recorder was a little damaged. The requirements that we saw, the 3,400 Gs and all that sort of thing, that's designed about the maximum forces that an airliner can put on the recorder. Okay, airliner flies at like Mach 0.9. Fighter jet flying at Mach like 2.4 into a mountain. Forces are a little higher, right? So they brought us the recorder's damaged. We opened up the recorder, we got the memory card out. The memory card was also had some damage to it, but the memory itself was fine. So we patched up the data, patched up the card, took the data off. There was a representative for both the aircraft manufacturer as well as the aircraft or a representative for the branch of the military there. Took the data off, we validated it, all the data. We store data, we have to have all these checksums and whatnot. We use CRC32 a lot in our data. I know CRC, yeah, I think that, yeah. So we use CRC32 a lot in our data. Sometimes it's CRC16, depending on what the size of the data is we're using, right? So we extract the data, we verify the CRCs, everything looks good. We do a sanity check on the data, everything looks good, fine, fantastic. We give it to them, they say, thank you very much. They leave. The next day I hear on the news, all those aircraft were grounded. found out that from that data, they were able to realize what the problem was. They grounded all of that type of aircraft. Took them 3 months to fix them all, and then they were all flying there. So that data that was in that recorder probably saved some other pilots from a crash. And that's the whole reason we do this, is flight recorders save lives. So I don't know if you can tell on here, it looks like a little bit of a runway, and it looks like somebody sprinkled some trash on the side. No, that's Fly Dubai Flight 981. Let me bring it up on here. I got my notes on this. So Flight Dubai 981, Boeing 737-800. Aborted its first landing, had to go into a landing holding pattern. They kept it in the holding pattern for 2 hours. 2 hours, which is an extremely long amount of time. This is at Dubai International Airport. They went to make a second landing, aborted the second landing. After it aborted the second landing, it went to a very sharp bank up and then crashed down. There's the recorder. As you see this part right here, this is actually the cockpit voice recorder. The round part on the right of the photo there, the round part on the right, that's that cockpit or the crash survival memory unit. That's intact. All the damage you see is the front end. That's the acquisition of the power supply, the signal conditioning, the EMI protection. That's all damaged. The memory in the back, undamaged. I'm taking it apart. We got all the data off, no problems. Okay, Embraer Phenom. This is a business jet. Went down in the UK. That is, yes, a parking lot, right? With the data in the recorder, they were able to determine that the issue was there was some flight conditions that caused an excess load for the pilot. Okay, you guys think about, okay, everybody here knows you don't text and drive, right? Think about driving, taking a phone call, texting, having a conversation with somebody next to you. And you have 3 dimensions that you're working with, not just 2 on a car. That's basically what happened to this pilot. It was so much of a pilot overload. He had so many things he was trying to do that the pilot crashed. German wings, flight 9525. This is our recorder. I do have a picture of the, so this is the cockpit voice recorder. This is the flight data recorder. This is the Airbus A320. Basically went nose down into the Alps. No had any clue what happened until they got the cockpit voice recorder and heard the cockpit voice recorder, and the cockpit voice recorder heard the pilot, the captain, get up to use the restroom. Co-pilot turns around, locks the door. What they call CFIT, controlled flight into terrain. Purposely pointed the aircraft straight down, killed everybody. Guy had some mental issues. There's you want to talk about every time they have an incident, they record data off, or get data off of flight and find out what's the matter. They end up changing the rules. This guy was unsuitable to fly. He had psychologists who said this person should not be flying. And you know what they did? The psychologist said, "Here, take this to your bosses and give them this." Yeah, exactly. It went in the trash can. He didn't tell anybody he wasn't supposed to fly. Now, when pilots undergo a psychological evaluation, no, that goes directly to the safety board for the company or for the country, not handed to the pilots as they turn this in. Okay, this, oh my goodness. You know, I've seen the data for a lot of these flights. I've read the NTSB reports or some of the foreign investigation reports. I've heard audio for some of these flights. This is one of those flights that makes you just face palm. This is coming out of Taipei and airport Taiwan, their small airport, not their big airport. This is a an ATR-72. They take off. The controller instantly alerts them, flame out right engine. Flame out right engine, no problem. You shut the right engine off. All these aircraft with 2 engines can fly with 1, not a problem. Flame out right engine, shut off the right engine. The pilots, flame out right engine, shut off left engine. Realized what they did. Put left engine back on. No, it doesn't work like that. They don't change like that. Pilot error. Not every 10 people survived out of the 58. It was here's them trying to get people out. Okay. Why are the flight recorders in water? Okay. Crash, especially if it isn't happens, anything happens in salt water. Removing the item from the salt water will make the oxidation happen really fast. So what they do is they keep it in salt water, and then they slowly push fresh water out, take salt water or fresh water in, salt water out, and they rotate that water until they can get all the salts off. Then they can remove it from the water and dry it off. Otherwise, if you take it out after it's been in salt water, as you're disassembling it, basically all the metal's corroding at that point in time. So they keep it in the water as long as possible. Let's see. Oh, okay. Another one of those. So let's see, this same one here. Right. So there's the flight data recorder. So 2014, this is a Airbus A320. All 162 people died. There was the pilot in command gets a notification that the rudder control system has suffered a non-critical failure. Okay. There are steps that the pilots are supposed to do. They're trained to do this. Instead, the captain performs, as he says, a non-standard reset of the flight control system. He turned it off and turned it back on again, people. The whole aircraft. When you turn off your entire flight control system, you don't fly anymore. I believe in the immortal words of Woody from Toy Story, that's falling with style, right? Everybody's like, yeah, you remember that now. Yeah, okay. I have small children, so. But yeah, I mean, that's what happened. He basically turned it off, turned it back on again. There are lots of other stories I can tell you on other data recovery, some of the military stuff. I can tell you kind of what happened, but I can't give much information. There are lots more commercial aircraft incidents. There's a lot of non-fatal incidents, non-injury incidents where still the recorder was used to find out what happened. But every time things get safer. So I talked about changing the world, right? So recorders came out in the 1950s. Australian gentlemen developed them in the 1950s. Over time, they've been making changes. So let's look at the most recent changes here. So in 2015, Air France 447, as I told you, it took them 2 years to find it. Back then, the beacons only had to output a certain energy, acoustic energy, for 30 days. They figured out that they were searching in the right area about 45 days afterwards, but the beacons weren't putting out that much energy anymore, so they made the change, 90 days. They'll probably be able to find it in 90 days. Next, tape recorders. Oh my goodness. 2019 tape recorders, and I brought this recorder because I wanted to show you guys. This is great. This has a tape cartridge in it. I don't want to pass this one around because it weighs like 50 pounds or something like that. Okay, so this would hold a tape cartridge in it. Okay, this would hold a tape cartridge. This is just a feed of mechanical engineering, really. This here, pass this around, take a look at it. You were allowed to fly with tape recorders up until 2019. 2019, people. Yes. Finally, no more tape recorders. Oh, by the way, this is US, Europe, Australia, US, Europe, Australia, Middle East, Japan, some of Southeast Asia. Everywhere else you can still fly with tape recorders. Decide you want to go down to South America, you're going to go see Machu Picchu. You're going to be on this plane. It probably has a tape-based recorder in it. All right. Next year, less than a year, 25 hours of voice recording as opposed to 2 hours of voice recording. Right now, all the recorders have to have 25 hours of flight data and 2 hours of voice. The purpose is voice takes up a lot of more room. Think about that. These memories used to be very small. I mean, we used to measure some of the memories in megabytes. Okay. Now we can measure them in gigabytes. There's not a problem anymore. But it was only 2 hours of audio. The belief is that if you had an incident, nothing from the audio from longer than 2 hours is going to help you. Stuff from the flight data might, but the audio wasn't. Well, Malaysia Airlines Flight 370, right? They still haven't found it. When you have aircraft that could fly on autopilot for 22 hours, you've recorded over that incident audio over 10 times by the time the airplane finally comes to the ground. So any audio you had is lost because we always record over the oldest data. Okay, it's all big circular buffers. Everything's a circular buffer. Everything's a circular buffer, right? So they said we got to go to 25 hours. Oh, by the way, when I first created this slide presentation for some other people, this originally said 2021. Then it said 2022. Now it says 2023. Because this is enforced not only on new aircraft, but they're also enforcing some of the older aircraft too when they go up for a new certificate. And you know, if you've got a fleet of several thousand aircraft, if you're a United, American, a Delta, Southwest, whatever, British Airways, Air France, you've got a ton of aircraft, and suddenly you have to update all the recorders at $25,000 a piece. It starts to get a little pricey, so they keep fighting it. By the way, they're not $25,000; they're cheaper than that. Anyway, and then a RIPS. So a RIPS is a recorder independent power supply, and what that does is that provides power to the cockpit voice recorder if the rest of the aircraft power goes away. A RIPS is it's a backup battery, and the reason you have the backup battery on the cockpit voice recorder, because I show you that cockpit area microphone that I passed around. That cockpit area microphone is actually powered by the recorder. It's not powered by the aircraft. So if the recorder has its own power in it, it can power that microphone, and now you're recording audio. Matter of fact, I don't know if this unit has it or not. I grabbed the wrong one. No, these things take a beating, but if I scratch the paint, I'll get killed. Some of them have a little box, little door right here that we can actually remove, and it actually has a RIPS built. This is the CBR without RIPS. I'm gonna grab one of those. But they want that battery backup. That way, in case the whole aircraft power goes away, the cockpit voice recorder is still recording that cockpit voice, even though the flight data sources are probably gone. So the flight data recorder is not recording anything. Your video probably went down as well, right? But you're able still to do that. Okay. Working in aerospace. Air travel is huge. Even after the pandemic, even after COVID and during COVID, it's still a big industry. I told you about urban air mobility, $9.1 billion by 2030, which is now under 8 years away. I think that number is low. I think that number is off by a factor of 5. I am just seeing, I'm constantly getting contacted. I do a lot of working with aircraft manufacturers to help them figure out what recorder they should have, what they need to record, that sort of thing. I'm getting more of those every day. So urban air mobility, huge. Said if you've got an opportunity to work in urban air mobility after you graduate, it's going to be a fun ride. U.S. to foreign military spending. The military never runs out of money. They're always making more aircraft. Drones. Again, this will be a big market. Sooner or later, you're going to order on Amazon, and 3 hours later, something's going to come over and drop it off your desk, right? It's coming. And as I said, working on airplanes is just plain cool. Not too long ago, a little bit of pun, I'm allowed that, right? Anyway, in November, I went over to Italy. I went to aircraft, and I got to play around with one of their jets. They had a recorder on it, and it wasn't doing what they thought it should be doing. So,
no te fui tarde porque yo
le
mandé
mensaje en la hangar, and there's jets there, and you have other jets over here that they're building. And, enjoyable. I wish I could take some photos, show you guys, but because I pull out the camera, they're like, you're not taking pictures. Right? Oh, I'm just checking my text messages. So I unfortunately don't have any good photos, but you know, it is pretty. All right, we can skip the mechanical side. Electrical software. Oh my goodness. That's, I mean, the survivability, the mechanical part, the survivability is a key part of these recorders. But when you talk about just avionics in general, or the recorders, we don't have enough engineers. We don't have enough hardware people. We don't have enough software people. We don't have enough firmware people. It's great. Our software guys love working on the recorders. Our hardware guys, I mean, everybody has a blast. So this little recorder, I'll just brag a little bit. So this little recorder here, right? So this little recorder, I actually have some circuit cards from inside there. That is, I call that my baby. That's known as the Survivor recorder. So the audio acquisition card that acquires all the audio, my design. The software, my architecture. The inner card communication, my architecture. The connector panel where the connectors are, my design until my boss decided he wanted to do something. Yeah, that got to be fun. Memory organization, my design. It's a blast. I mean, I've been working on the Survivor since we started the design in 2005-ish, and you know, that's in multiple military aircraft, F-15s, version of the F-35s, the Saab JAS-39 Gripen, the B-52, drones, multiple drones, and we have sold some to some people. That is in an undisclosed black program aircraft. So I can't tell you what that one is because I don't even know. But anyway, as you see, all these STEM majors, all have careers of flight recorders. You can just ignore the flight recorder part, put avionics up there, and it's basically the same. So if avionics is something you're interested in, it's a great career. Thank you very much. Feel free if you want to, if you have a question, you have a question about the presentation, you have a question about what it's like to actually be an engineer in the real world and not in school, because there is a difference. If you have a question of what's it like working for L3 Harris, or what's it like, you know, working in avionics, grab a card, please. My email is on there. My cell phone number is on there. You can send text, send me an email. Feel free. I also have some circuit cards I'll get out. You guys can take a look at them. I just didn't want to pass them around because, again, I stole them from the lab, and I think some of them may be functional. So we'll see. Yes.
What airline?
What airline do I fly with? I have no qualms flying with any airline. How about that in the U.S.? Okay. I was based. The division I was with before we moved down here to Florida was based out of Chicago. So my home airport was O'Hare, which is a big United one. So that's where a lot of my flights have been on. But if I'm flying on American or Delta or Southwest, I don't have a problem. So American, United, Delta, Southwest, I don't have a problem. I mean, I don't know any. I don't know anything about the safety. I don't know anything about the safety for Spirit. I don't know about the safety. I haven't dealt with Allegiant either. You know, I deal mostly on the military side of things. So great majority of my experience is on that, but I have done some stuff on the commercial side. But I mean, I don't know them as well. You know, they're so any incident. I will tell you first off. I know you guys are probably told Wikipedia is not a good source, but any aircraft incident, they have a wiki page on, and a lot of it's very good data. I go there to pull up some stuff. Matter of fact, some of these pictures are from wiki. They always have a link to the NTSB report or the BEA report or whatever it is. Those are I find them a fantastic read. I don't know, maybe it'd be good for you guys if you guys had a hard time going to sleep. Air France 447 was probably one of the most interesting reads. If you ask me what airline I won't fly on, I probably won't fly Air France. You guys have a couple minutes? I can tell you about Air France, the 447 flight. So it flew through a storm. Well, their storm scope showed a storm, and they had an opportunity to fly over or around or through. And the crew went fly through, which in and of itself is not a problem. The problem is that the storm that they saw was shielding from their radar a colder, worse storm behind. So it went through the one storm and got wet, went through the clouds, got wet. Right behind it was a cold front. Now, and realize that when you're at flight level 380, and flight level 380 is 38,000 feet. So when you're at flight level 380, flight level 400, your air temperature is about minus 40 degrees. Okay, it's cold. Well, when you suddenly get a massive amount of water on your aircraft at minus 40 degrees, it turns to ice very quickly. So you have Pitot tubes. So Pitot tubes work by having a port that is ambient pressure, and then it's a tube so that as you're going forward, it forces air into it. So you have a difference in pressure. And the difference in pressure can give you a lot of information. A lot of information. And your autopilots need that air data. It's called air data, okay, from the Pitot tubes. Well, this Airbus aircraft had 8 Pitot tubes on it. All 8 of them froze over. Done. Froze full. Because they flew through the one storm and basically got wet and then flash frozen. Okay. Now the other thing is that the Pitot tubes were different materials, or I'm sorry, all the same material. Normally they have aluminum and brass and steel. They have a couple different materials because they'll react a little bit. They were all the same material. Anyway, Pitot tubes all froze over. The autopilot went without the air data. I can't fly. Alerted the flight crew, you're in charge, you're flying now. Should be trained perfectly fine to do this. Not a problem. Notice I said should be trained. Pitot tubes also affect what's the stall indicator. Anyway, what happened is they took control. They decided they wanted to go higher. But when they went to go higher, they got into a stall condition. And a stall condition means that the airplane is no longer flying. Okay? It means you may be going forward, but you really don't have control of your thing. Matter of fact, and don't be afraid of that, because every airplane you've been on has stalled, because they stall to land. When they come into land, they stall to land, let it come down. Okay, stalling is a normal thing with the aircraft. It's not a problem, provided you know what to do. The air crew pulled back on the stick to put nose up. But one of the things with stall is stall means that the air going over your wings, giving you the lift, is not fast enough. I took ground school. I did not. I did one ground school class at pilot school, not because I didn't want to fly, because I was afraid I would like flying and it gets really expensive. But I wanted to take ground school to have an understanding for some of the terminology, right? So and the displays in the cockpit and stuff like that, I wanted to understand that. So even in ground school, we were told when you stall, you nose down. Stall, nose down, gain speed, get your airfoils lifting again, and you're fine. They lifted up. Well, they lifted so far up that the angle of attack, we talked about the angle of attack, right? The angle of attack increased beyond a certain thing. The stall detectors that are taking all this data in, one of the things they take in is your angle of attack, and they validate the data. They said, if your angle of attack is between plus or minus 20 degrees, and you have these other situations, you're in a stall situation. Notice I said if it's between plus or minus 20 degrees. So when they made the angle of attack 22 degrees, the stall indicator went, nope, and stopped alerting them they were in a stall condition. Yes. Anyway, there was the relief crew. So this was a transatlantic flight. So the main crew took off, main crew went to sleep, the relief crew was flying. Well, when it got into the situation, they got the main captain came in. And there are 4 people standing in this cockpit, 2 seated with hands on the controls. The relief first officer, or the main first officer, the main captain, relief crew's in there. And the crew is talking that when they put nose down, they get a stall condition. But when they pull nose up, they don't get a stall condition. What nobody paid attention to, and this was evident in the cockpit voice recorder report, is that your altimeter was spinning counterclockwise. Spence, you are dropping in altitude. And typically when you're in a situation where you've got that sort of thing, the crew manifests as somebody should be calling out airspeed, should be calling out altitude. So those are key things to flying a plane. Nobody called out anything. Meanwhile, the altitude, they're literally dropping almost tail first. They would put the nose down, the stall warning would come on, and they'd pull the nose back up, and the stall warning would go off. And they were under the impression that they were flying okay with like a 33-degree angle of attack. I mean, they were like this, right? And it wasn't until like 4,000 feet above the water that somebody finally realized that their altitude was at 4,000 feet. At that point in time, it's too late. You can't drop the nose down. So Air France 447 hit the Atlantic Ocean tail first, which caused it to break up into multiple pieces, spread out the debris. And yeah, I mean, I just read the report going, even I know you're in a stall condition, nose down, stall condition, nose down. I don't fly an Airbus A330, but I know stall condition, nose down. Yeah. So there are all those NTSB reports. There are links to them on all of the wiki pages for all those sort of things. There's some really interesting incidents out there. Some of them that are miraculous saves. Some that are just terrible incidents that you just cringe. You read this report and go, oh my goodness, I can't believe the incompetency of the flight crew and the 240 people that died, right? So, but anyway, I've got some stuff out here. Please feel free to come up here. I got circuit cards, I got some other stuff, and I'll let you guys get going. So.
Thanks everyone, and we'll see you next GBM.
Thanks, Sean. I really like